So we're going to start with comparing hydrolysis. ठीक है? अच्छा, the first part है ना, that's over. ठीक है? The first part was electrophilic substitution, which we did over here. It's gonna we did a lot of AS revision, or it's gonna we did all this electrophilic substitution and comparison of electrophilic substitution of yeah, कहाँ से यहाँ से as a comparison of different electrophilic substitution of different benzene related compounds. ठीक है? So bromination and nitration. And at the end, we also did right at the end we also did बिल्कुल end पे ना we did alkylation and acylation as well. ठीक है? So that was right. Okay, how do you attach a carbon chain and how do you, and that was also part of electrophilic kind of part of electrophilic substitution. अच्छा, but anyways ये अब next part कर रहे. So I've opened a new board. ठीक है, एक सेकंड यहाँ पे भी, and let me rename this board. अच्छा, part 2 है organic. Just one second. अच्छा, अब इसमें ये कि so the next part is we're going to talk about hydrolysis. अच्छा, कुछ questions का comparison करेंगे, so we're going to talk about those. So this is hydrolysis of chlorine related hydrolysis of Cl related compounds. ठीक है, although this is these are like 3 different chapters, but the question is like you get one question, and it's all. हाँ जी,
सर जो एएस के लाइक रिलेटेड था वो सारा खत्म हो गया ना इसमें से?
मतलब किस तरह इसमें फिर AS आएगी?
लाइक
इसमें AS आएगी,
ओके सर.
मतलब वो बेंजीन में भी AS आ रहा था. आई टोल्ड यू कि उसके कंपैरिजन आएंगे विद एल्कीन्स. तो मतलब यू शुड नो कि व्हाट्स गोइंग ऑन विद एल्कीन्स. ठीक है, तो यहाँ पे भी Cl related compounds, so in comparison they'll actually ask you AS things, AS stuff as well. अच्छा, so how many chlorine related compounds do you have? Hydrolysis, remember, is a reaction with water where or OH ions. अच्छा, starting with the first one, there's a chlorobenzene. ठीक है, chlorobenzene is this thing, and it's got a Cl and OH. No, sorry, OH. अच्छा, so just let's just call it. So let's call it chlorobenzene. That's so that's benzene with a Cl. That's the first chlorine-related compound. So then you have another one, which are your halogenalkanes. So for example, you've got CH3 and then बल्कि पूरी draw कर लेते हैं. So you got a couple of carbon atoms and they've got a Cl attached to it, and you've got H atoms. ठीक है, so that's a halogenalkane. ठीक है, ये आपने उसमें पढ़ा है AS के अंदर, halogeno alkanes. And then you have a third one, which is known as an acyl chloride. Now, an acyl chloride is this thing. It's let's say there's a carbon chain, and then there's going to be a serial bond O. अच्छा, मैं थोड़ा सा फॉर्मेट बता देता हूँ कि हम ऑर्गेनिक पढ़ इस तरह रहे हैं कि जिस तरह क्वेश्चंस आएंगे, वी नॉट स्टार्टिंग एट चैप्टर वाइज. बेसिकली वो इलेक्ट्रोफिलिक सब्स्टिट्यूशन जो था ना, आई मीन द प्रीवियस पार्ट दैट वी डिड, उसके अंदर ना वी डिड ऑल द इलेक्ट्रोफिलिक सब्स्टिट्यूशन. दे वर लाइक 3-4 डिफरेंट सब टॉपिक्स, तो हमने उनको मिला के पढ़ लिया. ठीक है, बिकॉज इलेक्ट्रोफिलिक सब्स्टिट्यूशन इज वन थीम. सो आई जस्ट did the entire electrophilic substitution. अच्छा ये भी तीन अलग अलग टॉपिक्स हैं, but we are studying it together because the question is going to be together. ठीक है, तो क्योंकि वो थीम उनकी एक ही है, so I've picked everything and I'm teaching it together. ठीक है, so this one is so this is your acyl chloride, ACYL. अच्छा, so you've got these three, कोई और तो नहीं है, नहीं बस तीन है. So you've got these three chlorine related compounds and their hydrolysis. The one that's on the right side, extreme right side, you've got this one is going to be strong hydrolysis. बल्कि very strong, vigorous hydrolysis. ठीक है, and the one that's on the extreme left, that's no hydrolysis. तो इसका hydrolysis होता ही नहीं है. अच्छा, बीच वाला ना, that's like somewhere in the middle. So the one on the right side, I'm talking about the reaction with water. So the one on the right side, the conditions and some observations for that is, okay, the reaction is even vigorous with cold water. You don't even need any conditions. You get vigorous reaction even with cold water. And you'll see fumes of HCl forming. White fumes, बल्कि. ठीक है, that's going to be your observation. The extreme left है, that obviously has no reaction. So the middle one, now you've done this in AS case के लिए ना, you would need NaOH aqueous, and you would need to heat with reflux. So it's not a vigorous reaction. I mean, just gonna heat करना पड़ा, तो obviously that one is not really a vigorous reaction. और जो आखिरी वाला ना, उसका जो मर्जी कर लो, there's no reaction, no hydrolysis. So we're gonna learn about the reasons for that. इसको थोड़ा सा मैं, अच्छा ये इसकी कंडीशंस है. और ये तो ठीक है, पहले तो बेसिक आइडिया. ठीक है, I've told you that the right one has the vigorous reaction, the left one absolutely has no reaction. So one by one, they're going to ask you about okay, why is one not hydrolyzing and why is the other one hydrolyzing rapidly. So one by one, we're going to talk about okay, what's going on. So the first one, we're going to start with this thing कि ये इसको क्या मसला है. तो no hydrolysis of chlorobenzene. So no hydrolysis of, so why is that? अच्छा उसमें उसको उठाते हैं. अच्छा, what is going to happen over here is hydrolysis is a reaction with water. What happens in chlorobenzene is when you have a chlorobenzene molecule, so when you have a chlorobenzene molecule, this Cl has a lot of lone pairs. And what those, so these Cls have a lot of lone pairs, 3 of them. What eventually happens is that the electron density, Cl is an electron donating group. ठीक है, it's वो ऊपर अगर पिछला पार्ट देख रहे हैं ना उसके अंदर it was यहाँ पे कहीं ना मतलब Cl कहीं पे था यहाँ पे. एक सेकेंड, इससे नीचे होगा, नहीं टॉप पे होगा, ये वाला. अच्छा, Cl is a 2,4. It's an electron donating group. ठीक है, it would push electron density onto the other onto benzene. So यहाँ पे what's going to happen is that this Cl over here is going to overlap with benzene's pi electron cloud, and the electron density over here will increase. And the electron density, all the other electrons are going to get pushed to the other side, so that will increase. So the overall effect is that there's going to be a very high electron density around this Cl. क्योंकि उसके लोन पेयर्स जो है ना वो बेंजीन इलेक्ट्रॉन क्लाउड they're all overlapping with each other. ठीक है, is this part clear? ये clear है?
सर
हाँ जी.
सर तो लाइक इलेक्ट्रॉन क्लोरीन के इर्द गिर्द लॉन पेयर्स है और वो वहाँ पे लाइक मिक्स करे ना बेंजीन के बाई इलेक्ट्रॉन क्लाउड से.
हाँ मतलब वो ये काम हो रहा है ना, वो जो ये वाला काम नहीं था जो अल्काइल चेंज नहीं कर रहे थे, वो भी वही कर रहे थे ना उसके बेंजीन के पाई इलेक्ट्रॉन क्लाउड. एंड यहाँ पे Cl के पास तो एक्स्ट्रा लोन पेयर्स, बहुत ज्यादा लोन पेयर्स है, सो दे ऑल स्टार्ट ओवरलैपिंग, सो देयर दिस ह्यूज इलेक्ट्रॉन क्लाउड ऑन दिस साइड. ठीक है.
ओके सर.
अच्छा, so now what happens is why does it not react with water? The reason it does not react with water or with OH ions is कि OH ions have a negative charge. So obviously it's not going to react. It's going to be repelled. ठीक है? Is that idea clear that a negative ion is going to be repelled by the high charge density electron cloud? By electron cloud. ठीक है, तो वो वाटर का भी यही होगा कि even if you're talking about water, the water lone pairs are going to be water क्या होता है, H2O होता है, तो water lone pairs are also going to be repelled. So it's neither going to react with OH minus 1 or with water. ठीक है, कि water का molecule होगा तो water का जो negative lone pairs हैं, they are not going to be attracted to that benzene or any of the carbons on this benzene. ठीक है, is this clear?
यस ये.
अच्छा, बाकी ये कि इसका ना प्रॉपर आंसर जो लिखोगे ना वो लिखोगे कि मतलब इसका प्रॉपर आंसर वही होगा कि I mean same thing, just in better words. That will be that the lone pair on Cl, they overlap with benzene's pi electron cloud, which increases the. तो यहाँ पे तो it's like the bond over here is now like a double bond or a triple bond because बहुत ज़्यादा electrons आ गए. ठीक है, they're all overlapping with each other. So the pi electron cloud, which increases the strength. So which increases the strength of the CCl bond, which repels OH ions. ठीक है, तो ये आपने आंसर लिखना है कि lone pair of Cl overlap with benzene's pi-electron cloud, which increases the strength यहाँ पे because there's too many electrons of the CCl, which repels the OH ions. बल्कि इसको मतलब और डिटेल में लिखना है कि which repels तो वो लिख दो कि so high, इसको बल्कि एंड वाले को और थोड़ा डिटेल में लिख देते हैं. So what happens is that the high charge density electron cloud repel OH ions, which are basically inherently nucleophiles. OH ions are looking for positive charge, they're not looking for negative charge. ठीक है, ये इसका आंसर है. अच्छा, इज दिस क्लियर? हाँ जी.
सर तो लाइक वो डायरेक्टली यही क्वेश्चन पूछेगा कि व्हाई देयर इज नो हाइड्रोलिसिस.
हाँ, मतलब पूरा डिटेल में पूछेगा ना इसका क्वेश्चन. मतलब वैसे ये देखना 9701 नहीं, वैसे ही क्लोरोबेंजीन में लिख देता हूँ. खैर, गूगल से क्वेश्चन ही यहाँ पे मैं दिखा देता हूँ, एक सेकेंड. जो क्वेश्चन में दिखा देता हूँ, अभी खोलना पड़ेगा सारा. वो क्वेश्चन इसी तरह होगा एग्जैक्टली. अच्छा, नेक्स्ट वन, इस पे आ जाते हैं. दिस वन हैलोजेनो अल्केन, दिस इज योर ओल्ड एएस. ठीक है, तो अब आ जाते हैं हाइड्रोलिसिस ऑफ हैलोजेनो अल्केन्स. ठीक है, लेट्स टॉक अबाउट इट. अच्छा, दिस इज एएस. अच्छा, हाइड्रोलिसिस ऑफ हैलोजेनो अल्केन्स, इसमें ना विल जस्ट क्विकली डू द ओल्ड रिएक्शंस. SN1 SN2 mechanisms. उसमें होता क्या था कि you would have a primary halogen. अच्छा, आपका number one, that's primary halogen. ठीक है, just a quick recap. This was SN2 mechanism. अच्छा, primary halogen में what's a primary halogen that the carbon chain had just the halogen or the alpha carbon had only one carbon chain attached to it, और बाकी दो जगहों पे ना there was 8 atoms that were attached to it. और इसका रिएक्शन होता था with OH ions, and the OH ions would eventually substitute it. ठीक है, तो आपका जो प्रोडक्ट बनता था, अच्छा, that product was के the Cl would get replaced by, there's going to be a substitution reaction, and your OH ions will get substituted by Cl. उसका जो नेगेटिव चार्ज है ना वो भी इसके पास आ जाता था। ठीक है, दैट्स योर, अच्छा दैट वाज योर रिएक्शन। और अच्छा, अब उसका मैकेनिज्म क्या होता था? द मैकेनिज्म ऑफ ऑफ दिस थिंग वाज कि firstly no carbocations were formed। ठीक है, what would happen is कि जो आपका halogen alkane है CH3CH2 and this carbon with Cl and you've got H and you've got another H। अच्छा, what would happen in this case is कि this bond is very polar, carbon is positive, slight positive, Cl is slight negative। The OH minus one nucleophile with its lone pairs will get attracted to this carbon atom। ठीक है, and this was your nucleophile। There were other nucleophiles as well। AS के अंदर not just OH ions, there were other nucleophiles as well like CN-1, वो भी होता था CN-1, and you also had ammonia as well, NH3 as well। ठीक है, that was a nucleophile as well। So the OH-1 will approach this carbon atom and at the same time electrons from this bond over here are going to they will be repelled। Next step, कि बारी बारी करके the electrons are getting repelled and the OH is coming closer to it। So there was a transition state that would form, and the transition state would look ये उसके H है, and the transition state would somewhat look like this कि आपका जो वो कौन सा है Cl is getting repelled and at the same time your OH ions are coming close to it। So it will be partially bonded to both of them at the same time। Finally, the last part is that the Cl is going to get knocked out। तो वो लास्ट पार्ट था और उसमें क्या होता था कि you would form the replacement will happen। ठीक है, it will be CH3CH2, then there's a C with H and there's another H और फिर यहाँ पे eventually the OH is going to take its place and the Cl is eventually going to get the Cl is eventually going to get knocked out। तो ये सब हो रहा है। ठीक है, ये सारा आपका मैकेनिज्म था। दिस वाज नोन एज द
सर
SN2। हाँ जी,
सर वन स्टेप मैकेनिज्म था ना?
हाँ ये वन स्टेप होता था। ठीक है, and it wasn't this was known as a transition state, not an intermediate। ठीक है, it was or we entire process that's a one step mechanism। तो सब कुछ ना वन स्टेप पे होता था। एंड that is basically your mechanism for this one। ये AS का है and this was called क्या कहते थे SN2। ठीक है, why was it called SN2? Because the rate of the reaction, because there was only one step, the rate of the reaction would depend on both reactants। ठीक है, SN2 का मतलब ये होता था कि there was only one step, so rate would depend on both reactants। अच्छा, it would depend on both reactants, ठीक है, ये उसका मतलब होता था. अच्छा, then you had another one which is इसके अलावा जो था ना, वो ये था कि इसमें और क्या इम्पोर्टेंट चीज़ है, कोई खास इम्पोर्टेंट चीज़ तो नहीं है. Just the conditions that you had NaOH aqueous and you had reflux. फिर एक इस पे होता था कि the other one, ठीक है, टर्शी का कर लेते हैं. तो जो आपका सेकेंड वन है ना, that's your अच्छा, सेकेंड वन इज योर टर्शी हैलोजेनोएल्केन.
सर
हाँ जी.
सर जो हमारे पास सेकंड जो होता था सर उसके अंदर SN1 SN2 मैकेनिज्म दोनों हो सकते थे.
हाँ, उस पर डिपेंड करता था कंडीशंस पे. अच्छा, टर्शी हैलोजेनोएल्केन का अ, ये सब कुछ तो सेम ही होता था, ठीक है. दिस वुड बी मैक्सिमम डिफरेंट होता था, कंडीशंस वगैरह एवरीथिंग वुड बी एग्जैक्टली द सेम. Tertiary halogenalkane had carbon chains, had 3 carbon chains on the alpha carbon atom. Okay, there would be a carbon chain on this side. तो दोनों sides पे carbon chain थे, ठीक है. So there would be let's say a CH3 over here, and there would be a CH3 over here as well. और यहाँ पे भी ना, this one will be, so you had CH3s on both. ठीक है, that was a tertiary halogenalkane. इसका जो mechanism होता था, that was a two-step mechanism. इसमें there would be a carbocation that would form. अच्छा, and in this two-step mechanism, carbocations were forming. तो एक सेकेंड. अच्छा, and here's how it happened. कि you had the first step was कि you're going to have a heterolytic fission. So there's a CH3, Cl over here, and a CH3 at the bottom as well. And the Cl would first break on its own. It was a slow step. The Cl was the one which would take the electrons heterolytically. तो आपका जो molecule है ना, that would turn into a carbocation. The carbon over here will get a positive charge. And the Cl is gone. Now, in the next step, what will happen is okay, the OH minus 1 is going to come in with its lone pairs, and it's going to get attracted to this carbon that's positive. Okay, so and eventually that happens. Okay, your molecule becomes complete again. It no longer is a carbocation. You'll have CH3, CH2. और यहाँ पे ना, there's a carbon with a CH3 and और आपका ना OH आ गया बीच में, ठीक है. और वो Cl माइनस पहले ही टूट के अलग हुआ हुआ है. अच्छा, but this time it's a proper two-step mechanism. It's not one step. पहले एक चीज होती है, then the other thing happens. So here's your step 1 and here's your step number. अच्छा, here's your step number 2. Uh, तो carbocations get formed. अच्छा, क्वेश्चन ये कि एक क्वेश्चन सिंपल सा, why is no carbocation formed in the first one? Why is a carbocation formed in the tertiary halogenoalkane? But why do tertiary halogenoalkanes prefer the formation of a carbocation?
सर वो पॉजिटिव चार्ज मतलब एक में ज्यादा स्टेबल होता है एक में नहीं होता.
उसकी रीजन होती है कि when you have more carbon chains, तो it's got a lot of electrons surrounding it. तो जो पॉजिटिव चार्ज होता है ना, वो इतना ज्यादा होता नहीं है. वो दिस पॉजिटिव चार्ज इज लाइक इट्स गॉट अ वेरी लो चार्ज डेंसिटी. ठीक है, रिमेंबर वी डिड डिस्कस दिस अर्लियर एज वेल. एल्कीन्स में वी डिड, वो जो मार्कोवनिकोव्स रूल, वी डिड डिस्कस दिस ओवर देयर एज वेल. कि a tertiary carbocation has a very low positive charge density because this positive charge is surrounded by a lot of electrons. So when you have a very small positive charge, it's easier to form a carbocation. ठीक है, यहाँ पे it's going to be very difficult to form a carbocation because the positive charge is going to be so large. ये जो positive charge है ना, it's not surrounded by electrons. Hydrogens हैं. On two sides you got hydrogens. So you don't have a lot of electrons around you. So the positive charge is like really big. So agar, if it's really big, that kind of means कि it's going to attract the OH minus one very, very strongly. तो वो positive charge इतना ज़्यादा होता है कि it simultaneously attracts the OH. At the same time, it's also attracting the Cl. Eventually, it can't make 5 bonds, so one of them has to leave. But because of the greater positive charge, a carbocation never gets formed. वो टाइम ही नहीं मिलता. वो उसी टाइम ना, as soon as the positive charge appears, at the same time it starts attracting the OH minus one. तो इसका बस आंसर है कि it's easier to form a tertiary carbocation. Cation, there's more electron donating alkyl chains around it. So you got more electron donating alkyl chains, so lower positive charge density. So you got a lower positive charge density, so it's a lot easier to form this carbocation. Or form hoga that's going to be stable. Immediately, it's not going to attract the OH minus one. So it's going to wait a while and then it's going to attract the OH minus one. So it's going to be a much slower reaction. It's going to take time. वो जो previous one होगा ना, that's going to be everything happening at the same time. The positive charge will be so big that it will be simultaneously attracting the OH ion as well. So you clear about hydrolysis of halogenalkanes? Is this clear?
Yes.
So there's nothing new in this one. This is all AS. अब वो आखिरी है, which is the third one. ठीक है, remember so the third one. This has normal conditions like moderate conditions. Now this one is going to be a very vigorous reaction. और इसका mechanism भी पूछेंगे. That's an acyl chloride. So the first part is the strong hydrolysis of acyl chloride. We इसका title देते हैं strong. So why do you have a very strong hydrolysis of? अच्छा, कोशिश करते हैं ये वाला पार्ट खत्म ही कर दें. ठीक है अभी. So why do you have a very strong hydrolysis of acyl chloride? First thing, okay, when you have an acyl chloride, so that has a double bond O and a Cl. Now, the basic thing is, the basic idea is that the carbon over here has a very strong positive charge. Why? Because it's attached to two electronegative atoms. मतलब वो भी partial negative and this is also slight negative. Electrons are being pulled on two sides. I mean, this is ये छोटा कर ले. So Cl is pulling electrons over here. Oxygen is pulling electrons in that direction. So that's why the carbon positive charge is like really large. ठीक है, ये idea clear है? तो if it's really large, so it doesn't even need OH ions. It just needs even water lone pairs would be sufficient. The water lone pairs are going to be very strongly attracted to it. हाँ जी.
सर अगर लाइक ये इलेक्ट्रोनेगेटिव लाइक स्ट्रांगली इलेक्ट्रोनेगेटिव है तो ये इसकी वजह से इसका पॉजिटिव चार्ज कम नहीं होगा कार्बन का?
ज्यादा होगा ना, उसके इलेक्ट्रॉन्स खींच के ऊपर ले गया, ये इलेक्ट्रॉन्स खींच के इधर ले गया.
ओके सर.
तो बेसिक आइडिया क्लियर है कि पहले तो बेसिक आइडिया कि देयर इज गोइंग टू बी अ वेरी विगरस रिएक्शन. ठीक है, बिकॉज द पॉजिटिव चार्ज, वो जो पिछला था ना हैलोजेनो अल्केन, there the positive charge was there but it wasn't that strong. ठीक है, जैसे यहाँ पे there was a positive charge but it wasn't very strong. मैं यहाँ पे ना वो positive charge भी लिख दूं, किधर है? Slight positive, slight negative. ठीक है, because there was only one Cl attached. तो पहला तो रीजन है कि रीजन एक्सप्लेनेशन फॉर व्हाई डू यू हैव अ विगरस रिएक्शन. ठीक है, तो कार्बन in acyl chloride is attached to two very electronegative elements. So it's attached to two very electronegative elements, which are oxygen and chlorine. So positive charge density is very high. So slight positive charge density or partial positive charge density is very high or very large. So the nucleophile, in this case, the water molecule. So your nucleophiles, water lone pairs, ठीक है, are very strongly attracted to it. ठीक है, that's the basic idea why the reaction is going to be very, very vigorous. Is this clear? ये clear है सारों को? बस मैं चाह रहा हूँ कि हाँ.
सर तो बेसिकली लाइक ये इसकी पॉजिटिव चार्ज कार्बन की इसलिए ज्यादा क्योंकि दो इलेक्ट्रोनेगेटिव एटम्स है और वो उसकी हाई पॉजिटिव चार्ज की वजह से वो अपने तरफ H2O को अट्रैक्ट कर सकता है ना.
हाँ, तो वाटर के लोन पे उसको बहुत स्ट्रांगली अट्रैक्ट करेगा. ठीक है, तो इसका बस वो ओवरऑल रिएक्शन होगा, इट्स गोइंग टू बी विद वाटर एंड इवन कोल्ड वाटर. ठीक है, वार्म वाटर के साथ रिएक्शन, तो कंडीशंस कोई स्पेसिफिक कंडीशंस नहीं होती, इट्स गोइंग टू हैपन vigorously anyways. ठीक है, तो the product is going to be CH3 CH2 C double bond O and OH. ठीक है, carboxylic acid is going to be formed and HCl molecules are going to be produced. ठीक है, so you'll see fumes of HCl in this case. तो यहाँ पे ना it's going to be, ये बेसिकली यहाँ पे ना Cl हट जाता है और OH आके अटैच हो जाता है. The Cl goes and bonds with the H. So this one is अच्छा, this one is no specific condition, room temperature, ठीक है. Vigorous reactions even with cold water. So even with cold water, or white fumes, misty fumes of HCl. मतलब बहुत ज्यादा produce होंगे. It's going to be a very vigorous reaction. So white fumes of HCl would also exist. अच्छा, but anyways, अब इसका ना there's a mechanism for this. बस last चीज है, ठीक है? There's a mechanism for this reaction, which is also in your course, and that mechanism is known as, for this exact reaction, that mechanism, you have to remember this mechanism by heart. That's an addition elimination mechanism. इसी चीज के लिए. अच्छा, addition elimination mechanism. What happens? अच्छा, what happens in this mechanism is कि ये है इसी का, ठीक है? तो ठीक है, same one. अच्छा, what happens in this mechanism is कि you start off with the first thing is you start off with let's say कोई acyl chloride है, ठीक है? CH3, same one, and I've got CH2, and there's a C double bond O and Cl. So the carbon is very strongly positive, and the Cl is slight negative, and this oxygen is also slight negative. अब जो आपका water molecules है ना, they're going to be attracted to it. तो water का जो lone pair है ना, one of the lone pairs is going to be attracted to this carbon positive. Make sure that the arrows are drawn exactly in this way. So when the water molecules approach the carbon atom, the electrons in the double bond are going to be, they're going to be repelled. ठीक है? That's the first step. ठीक है? That is what you're going to draw in the first step. अच्छा, फिर क्या होता है? The next part is, अच्छा, the next part is कि कॉपी क्यों नहीं हो रहा? तो ड्रॉ ही करना पड़ेगा. कॉपी, एक सेकेंड. पता नहीं. अच्छा, so next part is कि अब ये जो molecule है ना, what's going to happen is कि you've got CH3, CH2. The double bond O electrons have been repelled upwards. So the entire pi electron cloud in this double bond over here has been repelled upwards. Cl is right now at the moment not doing anything. So Cl is over here with its slight negative charge. And the water molecule has come in with its lone pairs, and it has bonded to this carbon atom. Okay? They've ended up forming a bond. So now the water molecule only has one lone pair left because one of the lone pairs has gotten attracted to this carbon atom. तो ठीक है लीजिए, ये एंड वाला पार्ट ना ये रिकॉर्डिंग में देख लेना. मैं बस कह रहा हूँ कि ये एक ही चीज है, तो एक ही उसमें खत्म हो जाए. ठीक है? You just have to remember this mechanism. So वो उसकी ना वॉच द रिकॉर्डिंग राइट एट द एंड, ठीक है। अच्छा, सो क्विकली इसको खत्म करते हैं। तो oxygen electrons got repelled. They accumulated on the top side over here, the double bond electrons over here. Water came in. Now water actually lost a lone pair, so water actually became positively. ये जो bottom pair water है, that actually became positively charged. ठीक है, because this water molecule ended up giving an electron to carbon. The double bond ended up giving electrons to the top. तो नीचे वाला positive हो गया, the top one is negative. Now the next step is these electrons that have accumulated on the top, they're going to come back. And they're going to reform the double bond. The double bond is going to be formed back again. But then when those electrons are coming back, electrons over here in this bond, they are repelled and the Cl leaves. Okay, that's the next part that's happening. So elimination has now started happening. तो पहले part में ये हुआ था कि an intermediate got formed. Now what's happening is the carbon double bond with oxygen has been reformed. But the Cl has left. ठीक है, that Cl has taken electrons away and is gone. और वो नीचे ना यहाँ पे अभी भी water attached है, ठीक है। It's got a lone pair and it's got a positive charge, ठीक है।
सर
हाँ जी।
सच तो बेसिकली जो लाइक वो इलेक्ट्रॉन थे डबल बॉन्ड के अंदर, वो पहले रिपेल हुए थे, वो फिर वापस आ गए और क्लोरीन उससे नॉकआउट हो गया ना।
हाँ, तो
ओके सर।
तो इंटरमीडिएट इस तरह बन रहा है कि पहले स्टेप पे ना इलेक्ट्रॉन्स सीएल के पास, मतलब सीएल पहले में नॉकआउट हो सकता, बट व्हाट हैपेंड इज वो जो डबल बॉन्डेड इलेक्ट्रॉन्स है ना, बिकॉज ऑक्सीजन इज मोर इलेक्ट्रोनेगेटिव, सो दोज इलेक्ट्रॉन्स गॉट रिपेल्ड, ठीक है। बट दे accumulated over here, they have no place to go, so eventually they're going to come back and Cl is going to get knocked out, ठीक है, and Cl leaves. अब लास्ट स्टेप है, this Cl is negatively charged, it's going to come back क्योंकि वो नेगेटिवली चार्ज है, इट इज अट्रैक्टेड टू पॉजिटिव चार्ज, ठीक है। सो दिस Cl, ये H है। अच्छा, now this Cl is going to come back and it's going to get attracted to one of the H's at the bottom over here. So what that H will do is कि the Cl electrons are going to get attracted to this H. वो जो ऑक्सीजन था ना, that needed a lone pair, so the H will give its electrons, it's going to give its electrons back. ये पॉजिटिव चार्ज इसको थोड़ा इधर कर लेते हैं, लोन पेयर को। So the H is going to give the electrons back, and the वो जो oxygen lone pairs हैं, they're going to get reformed. So the final product is going to be that you'll have what you'll have. So you're going to have a CH3, you're going to have a CH2, and you'll have a C double bond O, and now you'll have an OH at the bottom, and it's going to have two lone pairs. मतलब वो वापस normal OH बन गया, ठीक है। And the other thing that's going to be formed is an HCl gas molecule, ठीक है। That kind of completes your mechanism. तो इसको तो इतना सिंपल, ये थोड़ा सा डिटेल्ड है compared to the previous ones. So you got to remember this: the hydrolysis or addition elimination of acylchloride, and these are all the steps. I say last one ना actually कोई खास step नहीं है, the last one, the very last one, because it's a normal thing that वो जो lone pairs है ना, वो part आसान है. So again, starting from this one, water comes in, gets attracted to this carbon, oxygen electrons get repelled. Oxygen electrons accumulate on the top. ये क्या चीज आई हुई है? अच्छा, oxygen electrons, they accumulate on the top. They come back and Cl takes the electrons and तो Cl is gone, but your water at the bottom still has electron deficiency. It's got a lone pair missing. So the Cl minus 1 is going to come back and it's going to grab the H. The H is going to give the electrons back to the oxygen, and eventually the oxygen lone pairs are going to be formed back again. ठीक है, तो ये सारा आपका addition elimination, and you got to remember this one is important. ठीक है, क्योंकि typical A2 का mechanism है, so you'll probably be asked about this mechanism. 100 mark का पेपर है कुछ, तो they obviously there are a lot of questions. ठीक है, so a very likely question is going to come on addition elimination. ठीक है, ये
सर
clear? हाँ जी,
सर तो बेसिकली जो लास्ट हमारे पास हाइड्रोलिसिस था उसकी कंप्लीट मैकेनिज्म ये है ना हमारे पास।
हाँ ये वो लास्ट वाला addition elimination is strong hydrolysis of acylchlorides. ठीक है, तो ये tertiary halogenalkanes, primary halogenalkanes, क्लोरोबेंजीन नो हाइड्रोलिसिस, तो ये बेसिकली ना इस पूरी चीज का ना समरी है। ठीक है, क्लियर है बात?
यस सर।
तो चलो ठीक है, ये हो गया ये। लेट्स कंटिन्यू टुमारो देन। ठीक है,
ओके, अल्लाह हाफिज़।
ओके, हाफिज।